Okay, hi everyone. Welcome to this week. Today we're going to be discussing, like basically defining what routing is. So I'm going to go ahead and record this, share entire screen. Well, I'm already recording. I'm going to share my screen. Does everyone see this? See my Word document here? Everyone sees this?
Yep.
Okay.
You,
All right, so we're looking at the word route. What does it mean to route, or what is this word route? Well, there's a couple different things we can look at. We can look at the term router as in something that routes. We can look at something whether or not it's routable. Now, when it comes to routable, or whether we can define something as having routability, is the when we talk about that, we talk about this in terms of protocol. So there are some protocols that are routable, some that are not routable. So we'll look at that in just a second. And then there's the term routing. What do we define as routing? Okay, and actually for some reason I'm a little warm. Let me take off my shirt. My outer shirt. And I'm going to open this up. Okay. Now, a router is kind of shown right here. Now, interestingly enough, I drew this right here because I saw a picture of a router the other day, and it was interesting. It was a little on its side, kind of oval, and it showed this bottom part as kind of like a brick wall. Okay, and I thought that was cool. So when you think of what a router is, we can think of it as almost like a turret or a tower of a castle. So in like in old medieval times, you'd have a castle and you'd have this highest point, and then maybe you'd have this highest point could house people and weapons, and you're sitting there and you're protecting your people your people with arrows, cannons, guns, from the outsiders. You're protecting your castle from, being invaded, if you will. That's one way to look at a router. So this is what a router is. So you have your inside network. So we can define it as our network right here, the inside network. So you have printers and computers and servers and switches and everything that would make a local area network LAN happy, if you will. And then beyond is just anything else that is not your network. Okay. Now the other thing that routers do is they actually bring together disparate networks as well. So we'll have, you know, we'll have one network on this side. Maybe there is a network switch, and there's a bunch of PCs connected to the switch, and they're going to be all on the same local area network. Okay, and then it may bring together another network. And now, interesting thing about networks, okay, about routers. Sorry about that. And then again, this is the international symbol for router. This X is interesting thing is you don't have to. It can bring together different IP schemes or different IP families. So, in other words, on this side, you might have 200.1.1.0/24, and this side, we'll just bring this network. this could be something like 192.168.1.0/24, or this could be something like 27. And do you need a router to do this? Do we need a router for these two networks to bring these two networks together?
Yes.
Yeah, because they're in different network. They have different network IDs because this is /27, so they're divvied up into, let's see, 128.64 32s. They're divvied up by 32s. So this is the .0 network, and this is the .32 network. So now there's something interesting about routers. And we're still on this one. We haven't even spoken about this one or this one yet, but we will. There's something interesting about routers. It divvies up by IP address, which is true. But interestingly enough, sorry I keep on saying that word, but it is true. Interesting enough, I need to let somebody else in. Oh, D1, there's my man D1 James. How'd you like Sunday? Packers defeating whoever they defeated. Oh, the Cardinals. Anyways. Okay. So interestingly enough, a network router divvies up different IP addresses or with IP addresses with different network IDs as I depicted. But you can also bring together different layer 2 technologies. So let's take a look as an example. Can you see my can everyone see my packet tracer?
Yes.
Okay. So for example, we go to the router again, we grab a PT packet tracer router because it has already certain interfaces filled. It's if you go to the config tab, you can see that it already has some interface, some slots filled with different interfaces. I like it pre-filled, so I don't have to fill it up. But you can see there's 3 distinct technologies that this router is able to connect to each other. Here's fiber optic, which we'll talk about probably in another class, at another time. Okay, and we can take a look at this. Basic telephone. Oh, RJ11. This is here. Hold on. No, that's not it. Which one is this? Okay, here it is. FFE module provides one fast Ethernet interface for use with fiber media. So we have fiber optics right here. Here we have a serial connection. That's this right here. So you can look at these different modules that you have for this router. Now we can go to, let's say, this 1941. Let's do 2901. We can grab a 2901. We can click on it, and we go to config, and we can see that it has gig interfaces right here, and we can add more to it too. So if we go to the physical, we can add an HWIC, which is it adds a small form factor pluggable SFP. Which is high speed Ethernet. We have 2 serial links right here, and so what I'm saying is that if you grab different routers, they actually this actually has 4 switching ports, believe it or not. You can grab different routers have different capabilities. So I just wanted to show that, but I just want to get down on the basics right here. we can the two that we're going to bring together are a serial connection and an Ethernet connection, fast Ethernet connection. Now, they're both, believe it or not, they're both layer 2. So this is, let's say, we'll call this fast Ethernet, but let's just keep it simple and call it Ethernet. So this layer 2 technology is Ethernet, and it's basically what we all use. And it is the most popular layer 2 technology in 2025. But there's another type of technology that is out there. So this is going to necessitate yet another router. So let me just draw another router right here. And then on the other side of this router, let's just call it another Ethernet network. So it's just like you and I have experienced. But to link these routers together, many times you'll have like a serial, what we call a serial connection. Now, the serial connection, this connection has different attributes than the Ethernet connection. But they're both layer 2. So let me just say layer 2 type connections. We have two of them. We have on one side, we do have Ethernet. I'll just say ETH. On the other hand, I'll just say point-to-point protocol or serial link connection. Now, instead of me drawing everything, because my writing does not look very good at this point, I'm just going to type it here. So first off, speed. So this is going to be 100 megabits a second. Okay, that's fast Ethernet, and I'll just say fast for fast. Point to point, 1.54 megabits a second. So there's definitely a speed differential between the two. And also, I'm going to say mode. I know that's a bad word, but this is going to be LAN technology. And this is going to be WAN technology. So there is the traditional mindset is that the LAN technology has always been faster than WAN technology. Okay, and that is changing. That has changed in the last few years. In about 10 years ago, WAN technology really started to catch up, if you will, with the LAN technology. So LAN, it used to be the standard was 10 megabits a second, as you know from that base 10, from how I just described base 10 and whatnot. Now, and once base 10 started to be popular, then fast Ethernet became popular. And fast Ethernet was 100 megabits a second. Okay, that's when Cat 5 and Cat 6 cables came out and switching came out. Once switches dominated the layer 2 market, 100 megabits became the standard. So you recall, prior to the switch, there was the network bridge for layer 2, and then prior to that, there was a network hub, and then prior to that, there was just coaxial cable, in businesses. However, once switching came into play, layer 2 Ethernet was 100 megabits a second, and WAN speeds were basically 1.54 megabits a second. Now, some of you are like, well, wait a second. Who the heck would ever have want a connection that's only 1.54 megabits a second. And then this point to point, and I'm just going to go serial. I'll just do SE for serial. This basically was the foundation to derive T1 speeds. T1 generally refers to a speed of a point-to-point connection. Um, and the type of connection basically is what we call a CAS connection. CAS. But we have T1, T2, and as you go from T1 to T2 and then beyond, you're getting faster. You're getting multiples of 1.54 megabits a second. But even if you go 10 times, that's still only going to be right around 10 megabits a second, whereas layer 2, whereas Ethernet, fast Ethernet, is 100 megabits a second. I mean, you could run an entire factory with 100 megabits a second. That's amazing speed. So let me ask everyone this. Do you think T1 slash T2 point-to-point links are still being used today? What do you guys think?
Probably not.
Okay, well, unfortunately, my most recent enterprise experience was a couple years ago when I was at Stellantis. And I can tell you that many of the production centers, I'm talking about the assembly plants, okay, believe it or not, are still running T1 connections. Now this is strange. This is not what you think. So if you have a typical plant, I'll just say typical plant. And I'm gonna say at Chrysler, let's just say, you are going to have an entire enterprise here, right? But you'll have your front office, front office, because a lot of times an example of a plant might be Shep, Sterling Heights assembly plant. Now, in the assembly plant, you're going to have the plant floor here, but you're going to have the front offices here, and then you're going to have a lot of operations here. But the plant floor is here. I'll just say PF. Now, on the plant floor, you're going to have a lot of assembly lines moving parts across, and these assembly lines are connected to what we call PLCs. PLCs, as I'm sure you guys are confused now, I'll say PLC. I'll just write it right under here. PLC is equal to programmable logic controller. Now, what a programmable logic controller does is it's accepting short pieces. Somebody wants to join, I think. Here, 1 second. I got to stop. Okay. I have to let this go. I thought, okay, here we go. Okay. Anyways. So this programmable logic controller is getting instructions through the internet through essentially a data center, somewhere in Auburn Hills or even Sterling Heights. But whatever it is, it's away from the factory. Now these assembly and this doesn't have to be Shep, it's any assembly plant. Really any assembly plant for any automotive company, they're going to be using programmable logical controllers to run their assembly lines. And the link to these is a T1 connection. Okay? Now wait a second. Some of you might have a problem with this. What do you think? Is there an issue with this? Does anyone see an issue with this? You should. I mean, when I first started looking at this, I said, are you why are you using T1 lines? Why aren't you using like fast Ethernet? And the answer was, when it comes to WAN connections, you don't own the link. You can only subscribe to what there is to offer out there. Okay? So if the endpoints, if the computers, like usually you'll have a mainframe or something like that connected to in these data centers, and the mainframe is sending out information to the internet, and it's sending it through these pipes. Well, if the source and destination do not understand, if they don't have an interface for fast Ethernet, if their only interface is through point to point, then you're kind of stuck. But that being said, T1 lines are still being used. Okay? So the point is this, is that a router not only divides by IP address networks, or the network ID, it also divides by technology. So on one side, you can have fast Ethernet. So that's technically fast Ethernet right here. Not just Ethernet, it's fast Ethernet. On this side, you have point-to-point protocol, or better known as a serial connection. Or if you want to get faster than just a serial connection, you can have T1, T2, T3, and as the number after the T moves up, it's getting multiples of speed beyond 1. So T2 is 2 times 1.54. A T3 line is approximately 3 times 1.54. But again, it's still very slow, very much slower than fast Ethernet. So as I said, why do they even have this out there? It's because, number one, cost. These enterprises, Stellantis, you might think, well, they have all the money in the world. They sell cars. You can a Ram truck is, you can't even touch a Ram truck for less than 55 or 60,000. They should have all the, and then everyone's buying these Jeeps head over heels, and they even make Jeep style pickup trucks. So, why is Stellantis so cheap with their networking connections? And that's simply because there's so many, I'm going to say, so many locations of Stellantis all over the world, that they literally watch every dollar come across their way. So if they can save 10 cents by surviving, by this PLC still, this T1 line still chugging along the commands from the mainframe from somewhere else, then fine. And keep in mind, the commands that would go into a PLC, they're very short. They're very kind of like, they're almost like pulsating commands. The problem is that if this line is severed, or if there's too much congestion in here, then you can actually slow down or potentially even stop the assembly line right here, and that could be very costly. So for this reason, there's a lot of networking mechanisms to make sure that there's plenty of throughput. Although, how much throughput can you possibly have when it's based off of 1.54 megabits a second? But it is what it is. All right, so we went over what a router does, and we already knew what a router does anyways. I'm just giving you a little bit more detail. Let's talk about the idea of routable. What does it mean to be routable? To be routable means that it can communicate beyond just its local area network. So we recall that there were multiple layers of the OSI model. So there's layer 7, layer 6, layer 5, layer 4, layer 3, layer 2, layer 1. I'm just going to do layer 6, 7, 6, 5, 4, 3, 2, 1. Now the other aspect of this is the fact that this was the original OSI model, and there were 7 layers. Now, can somebody tell me one advantage that the TCP/IP model did to the OSI model? Are there more or less layers in the TCP/IP model?
It's less layers in the TCP.
Yes. So there were actually 2 things that the TCP/IP model did. It squished these upper layers into one, so now you just had, we'll just call it the application layer. Now, depending on the model you look at, you can even have 1 and 2 squished. So the data link and the physical layer, that looks like 2 P's. Let me just do D right there. Became I'll just say network access, NA. But that's all it did for the layers. But the other thing is it adjusted a key layer. So layer 4 was transport. Now transport was just brought back. So layer 4 just continued on being transport, and there's still TCP and UDP flavors. You recall that, I'm going to try to move this. Move this over here. Now you recall that the 2 layers of the transport layer were TCP and UDP. Transmission Control Protocol was connection based, and UDP was not connection based. Thus, it was a lighter type protocol. Now, the interesting thing was for layer 3, the problem with the OSI model wasn't just too many layers. It was the fact that the OSI model treated layer 3 as if it was still 1970. So it was doing Apple Talk. It was using examples of layer 3 as Apple Talk, NetBIOS, ArcNet. And while they were, layer 2 is like MAC addresses. They're not logical. They're unique. Okay? So I'm going to put it down here. L2 addressing or layer 2 addressing is always unique. So in other words, not logical. So in other words, if you have a layer 2 address, meaning MAC address essentially, your layer 2 address is like your driver's license, or it's like your social security number. There's supposed to be nothing like it. No one else in this world is supposed to be walking around with your social security number or with your student ID. If somebody had your student ID, they could be confused with you. And we see it a lot with data brokers. If you've ever heard about what happened in Spokio, like the Spokio is a data broker. So you go to Spokio and you pop in, you give somebody's name and their address, and you can investigate who they are. You can look them up and do background checks. The problem with Spokio and data brokers is that they can at times not be accurate, because you can have one person with the same, you can have 20 people with the same name as you, and the data broker could associate or link something that is happened to somebody else, but they could say because you have the same name as them, they could say it happened with you. And that's a problem when you don't have unique identifiers. L2 addressing is literally unique. So it is, so when they make these network cards, there's supposedly not two network cards with the same MAC address. That's an example. Layer 3 addressing under OSI model was logical, so it can be changed, and you can cascade addresses based on logic. But the problem is AppleTalk, NetBIOS, and ArcNet are from the old mainframe days. IBM. So mainframe was basically a big supercomputer located in your place of business, and all the offices, would be connected to that computer. But that data really wasn't going anywhere. Okay, could be backed up at at another location, but it's not like you're getting symmetrical connectivity or transmissions. It's just going out one way. So it's not really connected to them. So when TCP/IP came along, they said, wait a second. It's fine that layer 3, these three are logical, which means they can be changed, which means they can be used to connect each other under our umbrella of a network. But we need something to go outside of our network and specifically talk to one-on-one places that are geographically different than ours. So we need to, if we're in Iowa, and we need to speak to, and we need to dialogue or connect to a computer in Korea, we need to be able to do that. So in other words, we need something that can go outside of our borders. So we need something that can relate to different hardware types. And we see that right now. Like, for example, using your cell phone to go to Amazon and order a blanket or a new hat, a Tiger's hat, or a Lions hat, or a Green Bay Packers coffee cup. Okay? You're using your cell phone, which has a different hardware type, and then you're going outside of your modem to whatever connecting routers that ultimately connect you, and then finally you wind up with a router that is in the local area network of the PC that is serving the HTML of Amazon, and then you go to that. Okay? So what routing actually is, so now we're on whether or not it is routable. So can it do that? It depends. And literally the only routable protocol right now in the world is IP. Now, we talked about the different classes of IP. Class A, Class B, Class C. And there's even, that we'll even talk about, we might even be able to talk about it today. There is even Class D, which we'll talk about. But again, Class A, we know it's Class A by the first octet, from .1 to .126. Class B starts with .128 and goes all the way to .191. Class C goes all the way from 192 all the way to .223. And for those of you that were noticing it, that were aware of it, .127 was not mentioned, and that's because technically it is Class B, but it is your loopback address or your home page address. Okay, so we have, by going to the OSI model, we made a lot of, from the OSI to the TCP/IP, we've made a lot of good changes. because we now have TCP/IP people. The Department of Defense has given us our first routable protocol. When I say routable, I mean globally routable. Now, AppleTalk, NetBIOS, and ArcNet, you could call those routable, but they're only routable within their own network, meaning they're logical, and you can cascade them, around your local area network, but it isn't like you can go to another country or even to another building or to another entity. IP is literally global. Okay, so that's two of the main things that TCP/IP did. They were able to shrink the amount of layers, which helped the development process. Okay, because as you're developing products, what you're doing is you're developing it for the particular layer, but you need to interact with the layer above and the layer below. It's similar to mailing a letter. You're interacting with somehow you're interacting with the fundamental infrastructure of the mailing system, meaning you're touching the mailbox. You have to touch it in order for you to put it into the mailbox, and the mail person, the mailman or mailwoman, will be touching the same box to remove all that mail. So you're literally interacting with the layers below you when you mail a letter that enable the whole mail system to work. The mail lady will take the mail, she'll put it in her truck, she'll sort it or organize it, and then she drives it at the end of her shift to the mail place. It gets organized again, it goes on conveyor belts, and then it goes to big trucks and sometimes even jet planes. Actually, jet planes wind up delivering the mail to the eventual recipients. But you're touching it, you're being part of it when you open up that flap or that cabinet thing on the mailbox and then toss your mail in. Okay. All right, so let's take a look. We define whether something is routable. Let's take a look at the definition of routing. So routing defines our ability to talk to the world. So in other words, if I have two routers together, so let's pretend this is route R1, and here's R2. And here is Ethernet layer 2 technology on this side, Ethernet layer 2 technology on this side, and we have point-to-point connection for layer 2 on this side. So this is layer 2, this is layer 2, and this is layer 2. But when these routers talk to each other, they're talking to each other via layer 3. So the protocol for this layer 2 protocol is Ethernet. Same here. This layer 2 protocol, of course, we'll call a point-to-point protocol. And the protocol the layer 3 will be using will be IP. Now, what routing defines is that if we have a computer here, okay, the definition of routing is this PC has to communicate to this side. So this PC. So in other words, if this PC A wants to communicate to this PCB, So if A wants to communicate to B, okay, then it's one thing to have routers, okay, but to enable, so we have two routers, 1, 2, but we have to enable routing. We have to enable routing between for these two routers. So here's what I'm going to do. Does everyone see my packet tracer right here?
Yeah.
Okay, so I do apologize. I keep asking that, and I only ask that simply because I'm not sure whether or not Google Meet actually changes. Sometimes it changes it. Sometimes it shares all my screens. Sometimes it only shares some of them. It's really unpredictable. So okay, so we bring this router here. So we're gonna do what and actually I don't want to complicate things by adding new technologies. I'm just going to continue this. I'm just going to use an Ethernet cable between these two routers because I really want to underline what I'm about to tell you. And notice I am using symmetrical connections right here because I'm doing FA0 to FA0. And that's so important because when you're designing a network for real, for like a company, you don't always see the other side. You're not really sure. You don't always have access. See, when you're messing with these routers, you don't click on. There's nothing to click on and then go to the command line interface. What you wind up doing is taking a PC, and usually it'll be, let's say it's a laptop. So I'll connect this laptop to this, and I got to use a console cable. So I'll connect this console cable and I'll connect to RS-232, and I'll connect it to the console cable of this router. So when I connect to this laptop, and I go to the desktop, I can go to the terminal, and the defaults here are good. So I'm just going to go to OK, and I'm now inside this router right here. Okay, and it's the same thing as if I double clicked on the router. Did somebody just join? I want to make sure. Oh, okay, never mind. Okay, so now what I'm saying here is if we console into the router, this is what you see. But that's all you see, and this is very realistic to what you will be seeing and dealing with for real. So if this is a for real router, this is what you would see. You do not really see any connection coming out of here. You don't know what's going on because so many times you're telnetting or you're counseling into a router, and that's all you see is the command line interface. Okay, but anyways, let me do enable, and here's the other thing. In order to be successful in connecting to any router or switch, whether it's Cisco or any other brand, you're gonna have to know you're gonna have to know the language of that router. So Cisco almost has like another language. So I might as well go over it now. And I went over this before too. So the greater than sign is the user mode. The pound sign is the privileged or enable mode. And then when you see config or something like that, that's a global mode, and it gives you access. I'll just say comp, and that gives you access to the interfaces if you so choose. But even in the global configuration mode, you have access to the entire router or the entire device. So we're in the user mode now. To do anything of note, we have to at least get in the privilege mode. Okay, so in order to do that, we type in en tab, and then it auto completes to enable. So we're going to go to enable. Now, if we let's see, let me just see something. So if we want to go back to the user mode, which I don't know why anyone would, we type in log out. And that puts us back into user mode. But I don't know why anybody would do that. Now, to get back into enable mode, we can type in en, press tab, and it auto-completes enable, or we can type out enable, but because there's literally nothing else that en would auto-complete to, we can just type in enter, and we can get into that privileged or enable mode. Now this allows us to get to the global mode. To do that, we type in configure terminal. Okay? Now we can press question mark to see what our various objects, various choices are. We can do all this. And if we type in end, it goes back to the pound sign. Okay, and then we can type in log out to go back to the user mode. Now let's go back to enable and then configuration terminal or conf t. That gets us into the configuration mode. And what we want to do is we want to put IP addresses on here. And I'm not going to mess around with subnetting right now. Let's say on this side we have 200.1.1.0 network and we're not going to subnet. We're just going to do 200.1.2.0/24, and we're just going to do 192.168.1.0/24. I'm just demonstrating you the routing aspect. Okay, and I do apologize. It is 11:56. It's almost noon. Would you mind giving me about 15 more minutes? And I know technically it's 12:15. I mean, we don't get out till 12:15. But the problem is this is not going to last that long. So what I would like to do is close this for now, and then open it in another Google Meet. That way we have more time, okay?
Professor, the call says end in 10 minutes.
Yeah, it says those 10 minutes.
Yeah, so I want to close the call, reopen it, and I'm going to send you another link, and we can have more time. Does that make sense?
Yeah, okay, we can do that.
Yes, sir.
Okay. Unless you just want, you know what? Let's see what we can get done in 10 minutes. You ready?
Okay. Oh, okay.
All right, let's do it. Okay, so here's our IP address scheme, and I don't want to mess around with subnetting today. So I'm just gonna make sure that I make sure that the networks are divvied up here, just so everyone sees. So this is one network here, this is another network, and this is another network, and you can tell it's a network. It's a different network by the network IDs, various network IDs that we have here. So now notice this is a console cable. So this laptop does not have to have an IP address, as you can see. And it doesn't have an IP address. I mean, we can take a look at it. Go to desktop. IP configuration, there's no IP address. Because all we're doing, I don't know if you've ever heard of the term counseling in, it's like when you counsel into a device, what you're literally doing is becoming part of that device. You're physically becoming part of that device. So you can counsel into your microwave. You can counsel into your vacuum cleaner if it is a smart vacuum cleaner. You know, any smart device is going to have essentially a Linux ARM style computer connected to it, so you can get in, you can connect to it, and you can possibly run commands and control it. So this is what we're doing to this router. And now here, let me go back into this laptop. And again, okay, we're in the global command line. Now, here's another concept I want to teach you. The concept of a loopback button, a loopback interface. So there's different interfaces. So that's an interface FA00, and we can take a look at this laptop right here. We can look at this router right here, and we can see all the interfaces right here. FA00, 10, 20, 30, 40. Okay, and we can go back here, and I can type in exit, and we can do show IP interface brief, and we can see these are all the interfaces, but these are physical interfaces. Take a look at this router, and we can see at the physical tab, you can match these interfaces. Here's this connection, so that would be like FA40, and here's this connection, that would be serial 20, okay, and you can match it up. So these are literally physical connections. So if you put in fill this in with another notch, it's going to show up when you either here, maybe it wouldn't show up there, but it would show up on here. It would show up when you do show IP interface brief. It would show up under here. But there's another type of interface you can use. You can use a virtual interface. Now, in Cisco world, they call it a loopback interface. A loopback interface allows you to do different things. It allows you to do different types of tests. It allows you to pretend you have another interface if you're too lazy or to hook it up, or maybe, just maybe, you're not even near the router. Because, the router might be in some data center in India, and here you are in Michigan. You're not going to fly all the way out to that router just to, slide in, some sort of a copper interface or whatever. So you can actually, from the command line, install a virtual interface. So let's do that now. So to do any interface, we do configuration terminal, and then we can go, for example, go right into this interface. Interface F0/0. Okay? And just for the heck of it, we'll just turn it on. We'll do no shut. Change state to up. You can see it didn't change it on this side because the way it works is this side needs to be on and this side needs to be on. So we're not going to worry about that right now, and we'll just run a description interface F0/0. We'll go end, and then we can do show run int F00, and of course it won't do it. Let's just do a show run, and we can say that interface F00 description interface F00, no IP address, because we did not put an IP address on it. Now, let's go ahead and create our own loopback. So we'll go to config terminal, and then instead of saying interface F00 or F01 or whatever interfaces are on there, we're going to do interface loopback 1. Now we have created loopback 1, and for the heck of it, let's take a look and do a show IP interface brief, and we can actually see loopback 1 has been created. Now it doesn't show it here, but it will show it under in the command line interface. Now let's go ahead and let's X this out, and let's pretend this is for real. We're on our laptop right now, and let's give an IP address to loopback 1 within this local area network. Configuration T. Okay, and interface loopback 1 or L1, and we'll say IP address 200.1.1, and just so you know, interfaces, whether they're loopbacks or whatever, that are connected directly onto a router, you will always want to use the first available IP address in that scheme. So in this case, it's 200.1.1.1, and it's a /24. So if we just press enter, it will give me an error that says we need subnet mask. And actually, let me press return, and it says incomplete command because it's looking for the subnet mask. Okay, you have subnet mask, and let's give an IP address that matches this on this side. It'll be 200.1.2.1. That's to Fast Ethernet FA00. So from the interface, we can do int F00 and give it we can do no shut. I probably did before, but and let's do 200 IP address 200. Again, that's IP address 200.1.2.1 with a 255.255.255.0 subnet mask. Now, if we type in end and let's do show IP interface brief, we can see that loopback 1 is up and up, and we can see fast Ethernet 0 is 200.1.2.1. Notice that the protocol status is up, but the protocol is down. Now, can somebody tell me how is it that the status is up, but the protocol is down? I mean, the Ethernet is a protocol, but how can the protocol be down for this fast Ethernet? What do you guys think? Someone? Well, because I told you before that Ethernet requires both sides to be on. So if I go to this side, and you know what? I'm going to move this. I'm going to delete this console from here, and I'm literally going to move my laptop from here to here, and I'm going to reattach the console cable from this laptop RS-232 to this console right there. So now if I click on it and I go to terminal, go to OK, guess what? I'm in this. Just so you know, when it says, would you like to enter the initial configuration dialog, just type no. Okay, so now we're in this router, okay? And we're going to type in EN for enable. We're going to type in conf T to get into the global configuration mode. And then we're going to say interface F00. And then let's do no shutdown first. And we can see now that the interface is up. Now let's go to this router and type exit. Now let's do show IP interface brief, and we can now see that fast Ethernet, even though the IP address is unassigned, the status is up, but the protocol is up because the Ethernet connection requires at least both sides to be powered up. Okay, so now I'm going to give this. Now, because this is .1, let's give this .2. Okay, so IP address 200.1.2.2 with a 255.255.255.0 subnet mask. Now let's go to this and let's give it a loopback. Let's see, interface loopback 1. Now notice I also had a loopback 1 here, but it doesn't matter because they're on different routers. Okay, and I'm going to give this an IP address of 192.168.1.1 with a 255.255.255.0 IP address. Let's do show IP interface brief. And we can see everything's up and up. So that's one good thing. We can also do show IP and include only the interfaces that match. Okay, match the word up. Okay, so what we have here is show IP interface. That's the full. So show IP interface. Now, if all we did was that, it would literally show all the interfaces. That's a lot of information. So that's why the term show IP interface brief was created. But if we wanted to filter it down to only show the interfaces that show up, because we can see everything else is down, and these lists can be quite long, we can use include and regular expression. So we can use the word up, and it shows just all of them that are up. Now, if we can also do down, it would show all the down ones. So if you had a router with potentially many interfaces, you can have routers that are linked together and on the same data plane, and you can have hundreds of interfaces, and the show IP interface brief is just not going to cut it. If your boss says what interfaces are down, you're going to want to give him this as opposed to this, because if you wind up giving your boss this, and keep in mind, it could be hundreds of interfaces, you've just failed. If your boss just wanted the ones that are down, then you'd have to give him this. Anyways, now it's all completed. Okay, so let's see. Now here's another thing I want everyone to know, and that is what we call the extended ping. Okay, now let's say we go back to this router 0, and let's do ping 192.168.1. What did I say that was? Dot 1? Yeah, I said it was dot 1, I think. Let's see. Well, let's see. It's not doing it. Let's see if we can ping this side. And what was this side? Let's see. And I just want to include the ones that are up. And that side is 200.1.2.2. 200.1.2.2. And so it is successful at pinging this. Okay. Now let's see. Now this is what we call the ping. Ping stands for Packet Internet Groper, and that sees whether or not an interface is reachable or whether or not a host is reachable. But here's the thing: the problem is when you ping from a router, it presumes to ping from the closest interface to the destination. The closest interface is here, because it sees itself in this context as 200.1.2.1/24. That's what it sees itself as. What the problem is the router is also 200.1.1.1. We take a look at it. So if we did a show IP interface brief and include only the ones that are up, we can see that the loopback one is 200.1.1.1. So when I pinged this interface, it was successful. That's because it was pinging it from this side, because unless you ping something specifically, a router will always presume that the interface that you want to ping with is the interface closest to the destination, which in this case is the interface on this side. But we want to ping the interface on this side from the loopback. So this is where we do what we call the extended ping. The extended ping. Let's take a look. So to do the extended ping, we type in the word ping and we press enter. And we press enter for the default. So protocol is IP. Target IP address, okay, is 200.1.2.2. Repeat count 5, datagram size, timeout in seconds. Okay, so this gives us the ability to do extended commands, and we'll just say no for now, and then it works. But we didn't do the extended commands. Let's do the extended commands. Protocol IP, target IP address, 200.1.2.2, repeat count, datagram size, timeout in seconds. Extended commands, instead of just pressing enter, which will take the default of N, we press Y. Source address is 200.1.1.1. So we're doing it from this side. Okay, and it doesn't go. Nothing happens. It is not found. The reason why this side can get to the router, but this side can't, is because we have to apply routing. Wait a second, aren't we routing right now? No, all we did was we dragged two routers and then we connected them and then we properly applied IPs, but now we need to route them. What does it mean to route them? What I mean by routing them is the routers have to transmit their interfaces. Okay, what does this mean? It means it needs to send out to the globe or to everyone else who its directly connected networks are, and then it will broadcast the interface that is associated with that network. Let's take a look. So we can go to this command line interface, okay, and we can say, in order for these two outside networks, so that's the definition of routing, that this network on this side has to be able to communicate to a network on this side. And we do that with routing statements and routing protocols. Okay, one such protocol that we're going to talk about today is RIP. And it stands for Routing Information Protocol. So the way routers work, is they will transmit the IP addresses of this and this to everyone else, to everyone in the world. And, well, actually, not necessarily to everyone in the world, but to its neighbor. Routing is a neighbor-to-neighbor protocol. So if you have routers connecting to each other, So we have a router here, and a router here, and a router here, and a router here. This router is going to tell this guy what's going on, and this guy's going to tell this router what's going on. This router is going to tell this guy what's going on, and this router is going to tell this guy what's going on, assuming that they're connected. So let's connect these guys. Let's connect these guys, and let's connect these two routers. So this router is going to talk to this guy. This router is going to talk back. Okay, they're going to exchange. So when I say talk back, there's just an exchange of information. But that exchange occurs between these two routers. Now notice, that's only if they're connected, directly connected to each other. Now notice there's no connection between these two, so they're not directly sharing information. But if they were connected to each other, they would in fact be sharing information. Now, what information are they sharing? They're only sharing their directly connected networks. So, in this situation here, this router is communicating this network and this network. This router is communicating this network and this network. Okay, so how does it do it? Well, what you do is you go to the routers themselves, and then you go to your global configuration. Are we still connected, by the way? Oh, shit. Okay. Well, I had to start an instant meeting. Let's see. Well, anyways, you will have this recording. So what we do here, and let me just finish this up really quickly, so we can go to our router here, and we can go to configuration terminal, and then we can issue our network commands. So in order to enable RIP, okay, sorry about that. I wouldn't imagine many people are going to be here, going to come back again. Hey, how's it going? Hey, how's it going? Well, I'm just going to finish up as quickly as possible.
Hey, Professor.
Yeah. So anyways, I'm still recording. All we have to do is go to our router and apply our networking statements right here. And, now I'm kind of regretting doing this again, because now I have to wait for everyone to join again. I was recording this, so you could have caught the recording later. But anyways.
Professor,
Yes.
is it possible like you can record because I have a class at 12:30 and I'm.
Yeah, I'm recording it. So if you
Okay,
just want to leave, that's fine.
All right, bye.
Okay. Anyways, so what we're going to do, we're going to just apply the RIP networking statements. So we go to our router and we go to the global configuration mode, and then we do router, and then we can go to our question mark, and we can see all the different routing protocols it has, and we'll go through more of them another day. But let's look at RIP, router RIP, and press enter, and then we can just put in our networks.
I do have to get to work.
No. You can feel free to go. That's fine.
Okay.
Yeah, I'm recording this. I'm recording this. Don't worry about it.
Thank you so much. Okay.
All right, so we go back to here, and then we put router RIP, and then network, and then we just put in our networks 200.1.1.0 and network 200.2.0, 200.1.2.0, and that's it for router 0. We're done with router 0. Let's go to router 1. All we have to do is transmit 200.1.2.0 and 192.168.1.0. I know it doesn't seem intuitive. Some people are like, wait a second, we also know about 1.0. And the answer is we may know about it, but it's not very scalable for every router to have to put in every single network that there is. All every router has to do, you could have 10 routers connected to this in a cobweb, in a web of routers, but every single router has to do is just to transmit their directly connected networks. And what will happen is that the router will transmit the interfaces that are connected to that network. So again, we go to this, and all we're going to do is type in EN for enable, configuration terminal to get into the global configuration, and then we're going to type in router RIP and the networks, and we can type in 192.168.1.0 and then network 200.1.2.0, because those are the two networks that are directly connected to this router, and then we're going to press enter. Now RIP does not take long at all to converge, if you will, or to communicate with each other. So there are some tests that we can do right now. There are some commands. We're going to type in end for END, and then we're going to type in show IP route, and that actually tells us the fact that we are in fact using RIP, and R stands for RIP, and so in other words, this is saying show IP route tells the command show IP route outputs all of the networks that this router knows about, and it knows 192.168.1.0. Notice that's the network across the connected router. It knows it through R, RIP. Okay, and it's getting its information via fast Ethernet 00 right here. Okay, and we have 200.1.1/24 that we know about that network because it's directly connected via loopback 1. And then we know about 200.1.2.0 because it's directly connected via fast Ethernet 00. So if you read the output of show IP route, it tells you a lot of information. Okay? All right. That's it for now. You should be set up for success to do your homework. Thank you.